All right, today we're going to take a look at simplifying expressions that have exponents in them. And so we're going to look at three different exponent properties today and use those exponent properties to simplify lengthier expressions and see if we can simplify them down. So we're going to start by looking at a problem here, 9m to the third n, all raised to the fourth power, multiplied by 3m n to the fourth. So this is probably a medium level problem, probably in most Algebra 1 textbooks. And what they want you to be able to do is use the different exponent properties that we have to simplify this down. So when I look at a problem like this, I first look at where should I begin, where should I start? And anytime I see any parentheses, I usually want to start there because I have to think to myself, well, who does this fourth power belong to? It's outside the parentheses, so it belongs to everything in here. It belongs to the 9, it belongs to the m to the third, so we have m to the third to the fourth, and it also belongs to the n. So, I think in my head that goes to all those places. So I'm going to start by doing 9 to the fourth power. And if you're really good at mental math, you could probably do that. 9 to the fourth is 9 times 9 times 9 times 9. So that would take a lot of mental math to do. You could also grab a calculator and do 9 to the fourth power. And so if you did that, 9 to the fourth power would be 2,916. And so I just raised that 9 to the fourth power because it's on the outside, so it belongs to the 9 as well. Now I have m to the third to the fourth. So this is another exponent property. What is m to the third to the fourth? And because we're going to break it down, we're going to talk about that this is going to equal m to the 12th, but we want to talk about why the power of a power property works. When you see m to the third means m times m times m. But when you raise that to the fourth, that means you have these three m's here 4 separate times. So you really have these m times m times m 4 times, and they're all being multiplied by each other. So in total, there's 12. So one of the shortcuts we learn is m to the third to the fourth, power to a power. You just multiply the exponents to get m to the 12th. And so over here, m to the third to the fourth is m to the 12th. And then I'm going to look at the last thing in here, which is n, and it's just n to the fourth. So I'm going to write n to the fourth. And so I just did what's in parentheses, and I look over here. This fourth power here only belongs to the n, so there's nothing to simplify there. It only belongs to the n. And so I'm just going to bring this stuff straight down. So multiplied by 3m n to the fourth. Now I'm going to look at this problem and see, is there anything else I can do? Well, this is one long multiplication problem. This really reads 2,916 multiplied by m squared, multiplied by n to the fourth, multiplied by 3, multiplied by m, multiplied by n to the fourth. You won't see all these multiplication signs in between because we don't need to write them, but they're there. And we also know that we can rearrange multiplication, that it's commutative, that it doesn't matter the order in which we multiply. So I can multiply the 2,916 by 3, and I can kind of say, well, 2,916 times 3 turns into 8,748. Again, you'd want to use a calculator for that probably. And then we can keep multiplying down. We can say, well, I have m to the 12th. Now remember, m to the 12th is over here. That's these 12 m's. If I multiply it by another m, if I bring another m, that would give me a total of 13 m's multiplied together. So another rule we have is if you're multiplying powers, like m to the first times m to the 12th, m to the 12th times m, you would add the exponents. So it's m to the 13th. So when I multiply these m's together, I'm going to get m to the 13th. And then I'm going to look at multiplying the last things together, which is the n's. And n to the fourth times n to the fourth, using that same power we had before, that same property that says if you're multiplying these out, you add the exponents now, I would get n to the 8th. So we use three different properties in there to simplify that expression. And you're going to use those properties quite a bit. So you want to get really good at saying, well, what is x squared to the 5th? Well, if I see it like this, where it's a power to a power, it's like I have 2 of these 5 times, so I have a total of 10. So that's one of the properties. The other property we do a lot is x squared times x to the 5th. And if you're multiplying them, then we add them. So it would be x to the 7th. So those are two different properties we use quite a bit. And you're just going to kind of break a problem down step by step and try to use those powers and those properties to get the answer you're looking for. Just in case one example wasn't enough, let me show you one more. And we can look at 5a multiplied by the quantity 3ab to the third, all to the third. I'll walk through this one a little bit quicker, but still slow enough that you can see what we're doing. When I look at starting something like this, I always want to start with the parentheses. And I look and say there's a third power, so I want to apply it to everything in here, starting with the number 3. So my first thought is, what is 3? So think. So my little thought bubble over here is, what is 3 to the third power? Well, that means 3 times 3 times 3. So 3 to the third power is 27. Then I'm going to move down the line, and then I'm going to do a to the third power, which is just a to the third power. And then I'm going to do b to the third to the third. So what is b to the third all to the third? And if you remember, that's the one where we say, well, if it's a power to a power, the simplified property says just multiply the exponent. So that's going to become b to the 9th. So here I get 27, a to the third, b to the 9th. That's what the parentheses turn into. 3 to the third is 27, a to the third is a to the third, b to the third is b to the 9th. This is one of the times we want to multiply the 3 times the 3. Notice we're only multiplying the exponents. We're never going to multiply the coefficient or the number out front. We're going to raise it to a power. The properties only work with exponents. Now we're going to come back to the beginning and notice that we still have a 5a out front. So we're also going to multiply that 27 times 5. So out front we have 5 times 27. I'm always going to multiply the coefficients or the numbers together, and that's 135. And then I'm going to multiply the a's together. I have a multiplied by a to the third. So most of this stuff you can do it mentally. You don't need to write it down. I'll just usually do this mentally. A is just a to the first. The rule is to add the exponents when it looks like this. So that's a to the fourth. So this becomes 135 a to the fourth. And then the b doesn't have anything to combine with, so we're just going to bring that b straight down, and it would be b to the 9th. So 135 a to the fourth, b to the 9th. And that's kind of how we look at simplifying expressions using those 3 exponent properties.